Hi guys, and welcome to video 26 in the But How Do It Know companion video series. So now that our control section is finished down here, we can finally get down to programming our computer for the first time. So what do we mean by programming our computer? Well, we need to place instructions in RAM starting at address 0 before the clock actually starts running. So if we turn our CPU on here, once the power on reset signal is finished, since our clock is in manual mode, the clock stops and it's waiting for us to click on the button to make it advance. We can see that clock E is off, clock S is off. We are just before the beginning of the first clock cycle. So this would be a perfect time to come in and using our control signals, place some instructions in RAM, and then we could start the clock and see them execute. So one of the drawbacks of having wired our control section here using all these shift registers is that we have lost the ability to come in with a wire like we were doing before and simply turn on specific signals. Now we can't do that because these signals are always being driven either to 1 or to 0 by the shift registers. But which control signals do we need in order to program our instructions? It turns out that there's only two control signals that we need: mar set and ram set. So to program, we could set the RAM address here, click mar set the instruction to go at that address, click ram set. Continue this process until all of our instructions are in RAM, and then we can start our clock. So in order to do that, we need to have a way to set mar s and ram s either through the output of the shift register or through some other mechanism. And we can do this using an OR gate. So there is a bit of space here in which I'm going to build a temporary manual programming circuit that we'll be able to use to test our control unit out. This is going to be a temporary setup because programming a computer manually like this is very tedious and very long, and it's not something that we're going to do very often. Quickly, we're going to start leveraging our Arduino's memory and the capability of it loading the program initially for us in RAM. So let's build our manual programmer. First, let's install the SN74HC32 chip, which contains OR gate, and connect the manual inputs using pull-down resistors. Now let's remove the mar s and ram s wires so that we can send them to our OR gates and send the output back. Now let's make the final connections. So now we should be able to feed our mar s and ram s signals either by using the control signal that's sent by the shift registers or by manually setting one value here or here. So let's try it out. But before we can start programming, we need to decide which program we're actually going to run. Let's use the same one we've been using since the beginning, namely adding 20 and 22 together. So this table shows the byte values that we'll have to place in RAM starting at address 0 in order to put our program there. In address 0, we'll need to place the data instruction that says to load the value 20 in R0. At address 1, we have that value 20. At address 2, another data instruction specifying to load the value 22 in R1. So address 3 will contain that second value, 22. And finally, in address 4, we will have our add instruction that will add R0 to R1 and place the result in R1. Let's program it. So for this next bit, it will be helpful if you have the diagrams from page 112, 120, and 127 on hand. So when we start the clock, the first thing that's going to happen is that the first 3 steps of the stepper are going to load our first data instruction in the IR up here. So now we are at the end of step 3, and we can see that our data instruction, the first one, is loaded here into the IR. Now if we move to step 5 of the data instruction, we should see our number 20 being turned on to the bus here. Good. And then in the set phase, we will see the number being set to R0. We can see in fact that the R0 set signal down here is now turned on. Let's keep going. Now we will be going through steps 1, 2, 3 for the second instruction. Now we are at the end of step 3, you can see here, and our second data instruction is loaded into the IR. Here on step 5, we can see that our data is being enabled onto the bus. And during this set phase, it is now being stored into R1. Now let's move on to the last instruction, the add. So now, here we have our add instruction in the IR, add R0 to R1. We can see that in step 4, our reg B, R1, is enabled onto the bus. It's going to be set now into TMP. We can see the light turning on here. Let's move to step 5. In step 5, we will have our reg A being turned on to the bus. Now this is where our ALU computation is actually happening. Now in the set step, we see that the accumulator set signal is on, and now we are saving the result into the accumulator. Now here, at the beginning of step 6, we have enabled the accumulator, and we can see that the answer, 42, is being displayed here. So far everything is going well, and then in the set phase, we should see the destination register, namely R1, being set. And in fact, we can see the R1 set signal here being turned on. So now we have really reached a great milestone here where we have effectively programmed our computer for the first time. Now let's move on to learn about our next set of instructions. See you soon!